In our previous class, we have learned about the nature, charge, and mass of an alpha particle. In our this class, we are going to learn about the nature, charge, and mass of beta particle and gamma radiations. Beta particles are fast moving electrons emitted from the nucleus of an atom. A beta particle is nothing but exactly has the same structure of an electron with mass number as 0 and charge as -1. So beta particle is an electron that is being emitted from an active or a radioactive atom. Therefore, a beta particle is having negative charge as that of an electron and also the mass equal to the mass of an electron. In case of beta decay, consider an element X having mass number as A and atomic number as Z. When it undergoes beta decay, then an electron is released which is similar to a beta particle. The electron is having mass number as 0 and charge as -1. And this element after undergoing beta decay changes to a new element Y having mass number as A and atomic number as Z plus 1. Now we will check whether the right hand side is equal to the left hand side or not. Let us see A plus 0 is how much? It will be equal to A. So the mass number matches with the left hand side. The right hand side and left hand side mass number are same. Check the atomic number. Z plus 1 plus -1. So plus 1 and -1 will cancel and will leave you as Z, which is equal to the left hand side atomic number. So in both the sides, the mass number and atomic number are balanced. Therefore, the formula for beta decay is this. Carbon is having mass number 14 and atomic number 6. When it undergoes beta decay, it gives a new element which is known as the daughter element. Here, nitrogen is that daughter element. It is coming from carbon, so carbon was the parent element. Since there is a beta decay, so a beta particle will be released. Beta particle is having mass number as 0 and atomic number as -1. We will consider this as atomic number. In case of electron, this is the charge. So this is the charge. Actually, this is the charge. But in case of beta decay transformation, we will consider this as the atomic number. Now see what is happening. The mass number remains same. So 14 will remain as 14. The atomic number is increased by 1 in case of a beta decay. So 6 will change to 6 plus 1, which is 7. You have seen something new here, antineutrino. This you will learn in your senior classes. Gamma radiations are highly energetic electromagnetic waves. The wavelength of gamma radiations are less than the wavelength of the X-rays. Gamma radiations has no charge and no mass. Consider a source from which three kinds of rays are being emitted: alpha, beta and gamma rays. You can see alpha particle can only pass through the first stage, that is the paper. Beta particles can pass little more through the aluminium as well as the paper. Whereas gamma radiations has the highest penetrating power and can pass through all three of the elements present here: paper, aluminium and lead. So, the penetrating power, penetrating means passing through a particular substance, of gamma radiations are maximum. Then comes the beta rays and at the last you have the alpha particles or the alpha rays. The ionizing power of alpha particles are maximum. Then comes the beta particles and at the end we have the gamma radiations. Ionizing power means the ability to form ions. Alpha particles, when passing through molecules, can easily tend to attract electrons to them and therefore make the nearby molecules positive in charge. So, alpha particles have the maximum ionizing power. Then comes the electrons, which themselves are negatively charged. By electrons, I am meaning the beta particles. Beta particles itself, being negatively charged, has the less capacity compared to the alpha particle to make ions. And lastly, we are having the gamma radiations, which have the least capability to make ions. In case of gamma decay, there will be only change that the excited nucleus of the radioactive element will become a relaxed nucleus. There will be no change in mass or in the charge of the nucleus now formed after the release of the gamma radiations. The radioactive radiations are affected by the electric and magnetic field. It is seen that alpha particles are attracted towards the negative terminal, whereas the beta particles are attracted towards the positive terminal. And gamma radiations are seen to move undeflected from the radioactive element and being not attracted to either of the terminals. Thus, the alpha particles themselves are positively charged. Beta particles themselves are negatively charged and gamma radiations are uncharged. The deflection of alpha particle is less than that of beta particle. The reason behind that is the alpha particles are heavier in comparison to mass of the beta particles. So, they are deflected less compared to the beta particles. So, today your class ends here. Hope all of you have understood today's topic. Please complete all your homework and stay updated. Stay safe at home, enjoy the video classes and have fun. Take care. Thank you, class.